Imagine a planet so small and scorched that you'd assume it was nothing more than a dead, silent rock drifting through the void. But what if I told you that tucked beneath the surface of Mercury lies a secret that's breaking our understanding of planetary physics? We're talking about a core that's behaving like a massive, liquid dynamo that shouldn't even exist in a world this tiny. It's not just a rock, it's a powerhouse of strange, illegal physics that is forcing scientists to rewrite the rulebook of the solar system. Welcome to SciNova. Today we are diving deep, literally into the heart of the inner solar system. For decades, we viewed Mercury as the little brother of the planets, small, insignificant, and geologically boring. But recent data from recent missions and advanced modeling has turned that assumption on its head. We aren't just looking at a rock. We are looking at a complex, churning machine with a core that is much larger and much weirder than we ever imagined. Let's start with the first big shocker, the scale of the beast. For a long time, we thought we had a pretty good handle on Mercury's internal structure, but new research has revealed something startling. The core of Mercury is actually about 2,060 kilometers in size, which is a massive 50 kilometers larger than our previous estimates. This isn't just a minor rounding error. It's a fundamental shift in how we calculate the planet's mass and its entire evolutionary history. So, why does this extra 50 kilometers matter so much? In planetary science, size dictates everything, from how a planet cools to how it generates a magnetic field. Because the core is so much larger than we thought, it means the mantle, the rocky layer between the core and the surface, is much thinner than previously modeled. This creates a high-pressure environment that shouldn't be able to sustain the kind of activity we are seeing, making Mercury a true heavyweight in planetary physics. Now, let's talk about the illegal part, the magnetic field. Most planets generate a magnetic field through a process called a dynamo, where a rotating liquid metal core creates currents. Mercury has this, but it's doing it in a way that feels fundamentally broken. While it does possess a global magnetic field generated by convection in its liquid outer core, the geometry of that field is completely bizarre. It's not where it should be. Here is the kicker. Mercury's magnetic equator is displaced. Instead of being aligned with the planet's physical equator, the magnetic equator is shifted toward the north by approximately 20% of the planet's radius. This offset is massive. Imagine if Earth's magnetic North Pole suddenly decided to migrate halfway to the equator. It would throw every compass and biological navigation system into chaos. Scientists are still struggling to find a model that explains why this magnetic dipole is so lopsided. To understand how this happens, we have to look at what that core is actually made of. It isn't just pure iron. Recent studies suggest the core is a complex cocktail of iron mixed with silicon and sulfur. This chemical mixture is crucial because it lowers the melting point of the metal, keeping the core liquid even under the immense pressure of the planet's interior. This liquid metal is the engine of the dynamo, and its chemical composition is the key to its weird behavior. But wait, it gets even more exotic. There is a theory floating around the scientific community that Mercury might be hiding a literal treasure trove beneath its crust. Some research suggests that Mercury could contain a diamond layer up to 18 kilometers, or about 11 miles, thick, located just below its surface. The extreme pressures and carbon-rich environment could potentially forge a massive subterranean layer of diamonds that we are only just beginning to hypothesize. An 11-mile thick layer of diamonds? That sounds like something out of a science fiction novel, but in the high-pressure environment of a planet, it's physically plausible. If this layer exists, it would fundamentally change how heat moves from the core to the surface. It would act as a massive thermal insulator, trapping heat inside the planet and potentially fueling the very convection that keeps the liquid core churning. It turns Mercury into a literal pressure cooker of cosmic proportions. Let's look at the temperature inside this madness. We are talking about a core temperature range that swings between 2000 and 4000 Kelvin. That is incredibly hot, enough to melt almost anything we know on Earth. This intense heat, combined with the massive size of the core, creates a state of constant, violent convection. The liquid metal isn't just sitting there. It's rising and falling in massive molten plumes that drive the magnetic field. This brings us to a fascinating concept called top-down crystallization. In most planets, we expect the core to freeze from the inside out as the center cools first. But Mercury might be doing the opposite. Research suggests that solid, iron-rich material might be crystallizing at shallower depths within the core and then sinking toward the center. This top-down process would create a constant movement of material, adding even more energy to the dynamo and contributing to that weird, offset magnetic field. When you put all these pieces together, the oversized core, the chemical cocktail of sulfur and silicon, the possible diamond layer, and the top-down crystallization, you realize that Mercury is a planetary anomaly. It's a small world that is punching way above its weight class. It shouldn't have a magnetic field this complex, and it certainly shouldn't have a field that's so wildly displaced. It's a planet that defies the standard models of how rocky worlds are supposed to evolve. This discovery changes how we look at the rest of our solar system. If a planet as small as Mercury can host such a complex, high-energy interior, what are we missing about other planets? Could there be other impossible worlds out there, hiding diamond layers or strange magnetic anomalies that we simply haven't had the technology to see yet? Mercury is teaching us that in science, the smallest objects often hold the biggest secrets. The more we learn about Mercury, the more it feels less like a dead rock and more like a living, breathing engine of physics. It's a reminder that the universe is far more complex and far more illegal than our textbooks suggest. If you enjoyed this deep dive into the strange heart of Mercury, make sure to hit that subscribe button and ring the bell. We're constantly exploring the frontiers of science here at SciNova, and you won't want to miss what we uncover next. Thanks for watching.